Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. What did you study in school?
Well, it was a weaving path.
You were a basket weaver?
Yeah, almost.
Almost.
My journey through started out in kind of undetermined. Then it went to engineering.
Yeah, okay.
Then
that narrows it down to like a lot.
Yeah, to electrical engineering, but that came from actually, I think, in junior high school, I was in an electrical shop.
Oh, cool.
And that had tinged me, and also the Radio Shack 50-in-1 experiment, electronics experiment kit. That I got to build some circuits there. That was pretty cool.
That's cool.
But I first realized that engineering was very tough and took way too much, and had to stop for a while and go work, which I did for a year or two, and then went back and finished my electrical engineering degree in, I think it was 1982.
Yeah.
And so I have a BSEE from the University of Texas.
Wow.
And that was a tough road. Like most engineers, I understood about 70% or 60 to 70% in a 4-year program. Took five years or more to finish. Well, it's not that easy.
Did you have one of those classmates? I also had it was a major or the equivalent of a major in electrical engineering in undergrad. And one of the classmates, he ended up being a Rhodes Scholar. Wow. We had a project. We had to, create design a circuit, or you could, pick one up out of a magazine somewhere, and do the circuit analysis and build it, and then test it.
Yeah.
Was your circuit analysis correct? And that was the project for the semester. So most of us are designing, two-way lighting switch or some, ridiculously simple things, and maybe a resistor, maybe an RC circuit in it or something like that. And one of my classmates, the smart one, designed an equalizer.
Wow. Audio equalizer.
An audio equalizer. And then we had to make our own circuit boards. We etched our own boards. And
cool.
I remember going to New York City with him, and going through all of these old salvage yards for electronic parts. He was looking for all these odd parts, and because he needed 14 of them or 16 of them or something like that, so he could flush out the entire equalizer. He ended up using it in his dorm room for his stereo system.
Cool.
He got an A.
That's great.
He got an A.
Yeah. You have those guys that go well beyond what the minimum, and are just smart, or it's fun for them. So they do that, as an enjoyment. And I liked it too. I mean, for me, Fortran was very frustrating, and yet I came out with an A because it was me versus the computer.
Yeah.
And I was going to win.
That's right. I had very similar experience.
I'm back when you had those little cards, we had punch cards.
Yeah. Yeah, I do remember those. But the idea is that the reason I ask is I was looking through, and I get recruiters contacting me almost every day nowadays.
Yeah.
Are you interested? What the latest one was for an 18-month project with Microsoft as a test engineer. And the whole description, I went on and on. The whole description was design tests so that you can show that the design meets the specification. And I'm like, you guys, that could be a whole episode all by itself. And it went on, you had to have a BS in this and so many years experience and blah, 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 blah. And I'm like, no, you don't.
No, you don't.
No.
Right.
You don't.
And this is kind of an argument in the industry, I think, that has been for a while, that hiring for, specific, he knows this system or this system, is really not as advantageous as hiring a person who's motivated and has learned things and has shown that they can pick up and learn something new. And it's just a good person gets well along with either.
It's
Those may be
thoughtful,
more important.
considerate, all these, the soft skill
Yeah, all
type
the
stuff.
things, right? The soft skills, those could make a person more successful than just knowing exactly. And whether the degree is necessary for anything depending on really a lot of it's whether it's highly technical, like medicine or I definitely want a doctor to have gone through a formal training, and I definitely want engineers to have gone through. But I have known, and you may have known some engineers that are titled engineers that don't have an engineering degree. Have you known those people that are
yeah.
good?
Yeah, I've known people that don't have I grew up in a house where my father, he didn't go to college. He took a few classes here and there, but he got licensed as an architect.
Wow.
And
and that's a tough degree to get if you do get a degree.
Right. No, but he got licensed in a number of different states and, made a career out of it. He had to do a lot of work to get there, but he did.
So you and I know people that I knew Charlie Felkins, and if Charlie's listening, that'd be great.
Mm-hmm.
He was one that he helped Greg Hobbs with the engineering of pneumatic hammers for halt tables. And Charlie was brilliant about this. He knew how the pistons worked, and he learned what he needed to know to make these things happen, and also reverse engineer. But he was one of the best I knew, and he never got a college degree.
Yeah.
Now you ask, Steve Jobs or Bill Gates.
Well, I knew you were going to go there with those guys. They're the exceptions to the rule.
Right. And they had people under them that had degrees that knew what to do and were highly technical. I don't know if Steve Wozniak actually had a degree, but he learned, I think he was in the little hobbyist club.
Yeah. But it was that curiosity and passion and desire to learn.
Exactly.
And you can go solve these things. And it makes for a good college. So I mean, what prompted this? Yeah, what prompted this question is I don't know, a couple months ago, I got a question. What's the value of a CRE certification from ASQ overseas? And so I think Carl and I talked about that. And but as I'm seeing job openings and they list that it's boilerplate from the HR department, you need these degrees and blah, blah, blah.
Right.
And I'm like, no, you don't. You already have a tough market and you're looking for somebody that's going to get, $20 an hour, and they'd be better off working down at the grocery store because they're paying more than that these days to design test. And the other issue I had with this job opening, which is probably a whole nother episode, is we want you to design test to prove that the design meets specifications. Well, who cares? One, do you have the right specification?
Right.
Two, it's just like, no, we don't design, we don't build, we don't test in reliability. That's just not the concept here, guys.
No, you can't test in reliability.
You can't test in reliability. And I was like, no, that's just a place to not start. And so I wrote back to the recruiter saying, one, you didn't look at my resume. Two, if you really want to help your client, help them figure out what they really need,
right?
Which is not what you're asking for, and so on. And one of the guys, and this is a guy I met when I was working at Microsoft. He was a contract guy there, and I called him the super tech. This guy, he sounded like Charlie. He was a guy that'd say, hey, we need to do this kind of thing to do a stress test, basically. Right. And it was basically to find out how much stress happens when somebody steps on a product or sits on a product, and is that a problem with ours? Are we anywhere close to this? And he went off and he found some strain gauges and a bunch of other stuff. And he measured a bunch of there's 3-point bend tests basically, but we actually put the product on a couch and instrumented it and measured it. Yeah. And you'd break your butt bone before you'd break this product. So, it's all right. We're good. We got a lot of margin there.
Exactly. The user will probably stop before it hurts too much.
That's right. But it was one of these things. What we ended up doing it was a plastic casing. Is we took it to fracture because we wanted to see if it would deform
Right.
under intense loads, or would it
Right.
shatter and have a bunch of sharp edges?
Right.
And stepping on it with barefoot, yeah, a safety issue. So we kind of focused on that rather than
Right.
how many times somebody's going to sit on it. But the idea of, I mean, I was surprised when we were chatting just briefly before we started recording. It was like, well, who offers degrees in reliability besides CalSys? Well, there's 3 reliability degrees just at University of Maryland from different departments. And there's University of Kentucky, I think it is, or Tennessee or Kentucky. Somewhere out there is one more maintenance. There's University of Arizona. And those are the ones off the top of my head in the U.S. There's Miami, Toronto. There's 3 or 4 universities in England. There's a handful in China. One I actually taught a class at. But they're all over the world. There's one in Norway, and that offer masters or PhDs in reliability engineering.
And Fred, the basic thing I would ask them is, are they teaching methodologies on how to find unreliability, and are they teaching methodologies to, do root cause analysis and teaching some of the typical mechanisms? The problem I have is there's not any.
Of course not.
with reliability, it can be so different from product to product, from generation to generation, things that sneak in. I rarely ever see a pattern. The things that CALS and these companies can address are essentially what are intrinsic wear out modes of devices, and possibly, some of the potential variations of those. But right now, most of the articles I see from CALS, which is the one I do kind of follow, is typical issues with lithium-ion batteries. That's a big focus right now.
Yeah.
And that's smart. That's good. That's great, because, they are a limitation in all electronic battery-operated products, and we're all looking for the better battery, hopefully, in the future.
Yep.
But those kind of things are typical patterns, but you can't go... they don't address manufacturing variation or manufacturing excursions or things that really are the joy.
They have. I remember going back with multi-layer ceramic capacitors and different manufacturing processes. And what I learned there was that when I go tour factories making these capacitors for us, I knew exactly what to look for, because I knew more about their process and the failure mechanisms that come from it than they did. And it was because of CALS, the work done at CALS, to understand variations of temperatures, variation of pressures, variations of materials and sintering, and variations and all kinds of purities.
Right.
And I could ask questions, and these guys were looking at me like, how the hell you know that? I'm like, well, I read the paper. I didn't write it. I read it.
No, and it told you what the variables are, and some of the mechanisms, and, multi-layer ceramic MLCCs are very, very scattered through all over the electronics industry. I mean, there are so many applications, everything. And they're tiny little 0402, type chips.
Even smaller
than a grain, smaller than a grain of rice. So, and they're manufactured in billions at a time. They're just like chips. They're just billions. So trying to control the kind of variation in those processes, that's certainly part of the manufacturer's responsibility. But one time I had a bunch of reactors come in, and they'd all blown up inside the encapsulant, but they were still working because they were reactors and they didn't have current running through them. They were only used to have act as a variable capacitor electrically, and so. But that was just a one-time lot of variation that somebody, when you're making thousands of these 0402 reactors in a big tape reel, it could be that the tester had a ESD or some kind of transient that caused these things to burn up, but yet still function. Destroy the wire to the diode, but actually conduct voltage to the diode so it function.
Yeah. Now there's a story behind every one of these.
Yeah,
We
exactly.
could go on, and we have on these. But the idea is that you don't need a degree to ask good questions doing root cause analysis, But if you get into the material science of it, having somebody that really understands material science of ceramics comes in pretty handy because they have a different view on it.
It does. But I'd also couple that with the field experience or experience in reality. In other words, having experience in the industry or learning on their own or actually doing a SCM, analysis, scanning and optical microscopes and measurements and things like that. That's really leads to a lot other than just the mathematics and calculations behind it. But, experience, I'd say, and as you talked about previously with the other employees, somebody who has a drive to just ask the questions why. Why did this fail?
Yeah.
Why did that happen? And, the 5 or 10 or 15 questions it takes to get to the answer.
Yeah.
And that's really part of it is having experience in what has been unreliable, why it's been unreliable, and where those things can occur, in the design and in manufacturing process. That's the most important thing. And so experience in doing, an FA lab. I would hire somebody that had FA experience.
Yeah.
I would hire somebody that had a field service experience, went out like I did and installed and serviced equipment.
Oh, that's convenient. You'd hire yourself. Okay, I get it. Just kidding. No.
I've never been an FA. I've never been an FA.
But you've done plenty of it, and you've worked with plenty of processes to sort that out.
I've worked with FA engineers, right?
Now, as in the earlier discussion, I think it was with Carl about ASQ CRE certification.
Yes.
A degree, whether it's in reliability engineering or not, and I have a whole different take. I think you need product or plant, facility. You need experience and a degree in that area that you're going to be working in, with practical experience on the floor or in the lab or wherever. Then go into reliability and get your degree. I think is a much more powerful pass because just like any of these programs,
agree.
Just because you went to the right school and you got the right degree, you might be an absolute bummer, horrible programmer or engineer or surgeon or whoever. Yeah. You can be really, really bad at it. The idea of a degree, in at least my limited understanding of it, it exposes you to things that you didn't know existed. Here's some books, here's some stuff, here's some things, here's some ideas. Right. It gives you exposure to things. And the same with the certification program. It says, here's a range of different things that are available. And we know some of those are good and some are crap. But
some of them are misleading too.
Yeah, there's all that.
Crap.
But the idea is that if somebody goes through university and is just, when I had classmates like this, they would stay up all night, learn exactly what they needed for the test, and then never knew anything else about that topic afterwards. I mean, I had one guy who was an honors student, so to speak, in getting straight A's, and he's in advanced civil engineering because it was the easiest degree at the school. And he didn't know calculus, and he was worried about it being on one test. So he's come back over to me to help him get him tutored just for that test at the end of the quarter. I'm like, you're going to go out and design stuff? I don't think so. And employers can see through that pretty quick. When you don't put substance behind your resume, just because you have a BS in electrical engineering, if you don't know where to put your finger or not put your finger, an high voltage circuit, your degree's not worth the paper it's written on. And so I think there's that issue.
Right. It's school gives you lots of understanding, and your degree is in physics and statistics, as I understand it, right?
Master's in physics. Master's in physics with a double major with electrical engineering, and a master's in statistics.
Right. So, the engineering part really helped you, and none of them were, it's all kind of, I'd say a guy that knows physics and the material science is also excellent. But there is the ideal of college or the ideal of school because they can only teach what is kind of the nominal things. But as far as practical knowledge and getting in there and getting to work with people and realizing that sometimes the unreliability or reliability is caused by mistakes by people, and they certainly are want to protect themselves from being blamed. So that's especially with reliability, it's a very tricky area to be. You have to be diplomatic in some ways, but the real understanding of it is in getting into your company and knowing that product, because there's so much. I mean, from downwell logging, oil well logging equipment, to space, aircraft, JPL, NASA stuff. They're just going to be different worlds, and the realities aren't covered in school. I mean,
but it's one of those where if you're taking a class, if you're sitting in any class, it's over the top theoretical. It's a fair question to say, how in the world am I ever going to use this? What is the point of learning this if I can't use it in the real world? Because it's the fourth order, nano flip on a biobot over in the left-hand corner or something, and nobody in the world is there. Now, if you want to become the world's renowned expert in just that and hope it becomes a product someday, you're in good shape. But the idea is that, and I agree with you, is the degree. I mean, when it's done well, when you actually are inquisitive and want to learn and pick up lots of information and learn the language of these different disciplines and techniques and models, you can walk into a problem and go, oh, we need this process, or here's a good place to start, or here's a way to look at it, or here's something I learned about material science that let's go to the lab and figure it out. Right. And it just gives you another set of perspective that you can draw on to help solve problems or to avoid problems. But the other thing that a degree does, and it's been part of our society for a while, is that it gets past the filters for job applications. If they're, say, we want a BS in electrical engineering and you have a BS in mechanical engineering, the machine's going to kick you out as going not qualified. Even though all your experience is electrical engineering, all your resume talks about all that stuff, all your background for 40 years is designing electronic circuits, it won't get past the bot, Right. So part of it is it's a part of the degree, it's part of this other thing. The resume is not the end all for everything. Is make sure that your online resume is solid if you're looking for a new position. But once you get that interview, you got to walk the talk, I guess or talk the walk. Whatever the phrase is. You got to ask intelligent questions. You got to, answer based on your experience and be honest and truthful. This is the way you approach it. All of those things matter. Degree, to some extent, if taken advantage of, is a point in your life when you can dive into books. You can ask all kinds of questions. It's a safe place for you to just absorb knowledge. And too many people, in my opinion, waste that time. And then their degree is not worth anything. And then they struggle to find a job or keep a job when somebody says, hey, I need you to design this test or this circuit or whatever. And they don't know the first thing about it and don't want to learn. They're out of it.
That's why I think Cincinnati has many engineering cooperative degrees where the students actually work inside the factory. I mean, they actually, and that to me would be a huge advantage that they come out with already some industry experience. And that's what, so many kids right out of college are missing. And there's so many other things beyond the technical, but you should know the reflow temperature of lead solder and lead-free solder. You should know some of the some of the actual specifications and materials. But
you and I don't. We both use solder over our lives in all kinds of industries and products and so on. But neither one of us, I think, can explain at the metallic or the material science level what is eutectic.
Right. Right.
I don't. I kind of know what it is. It kind of melts all at once.
Yeah.
But why
Exactly.
or how that does it, I don't really know.
Exactly. But do I need to know? No. If I
No.
do, I'll go to somebody that's a solder. I'll go to the solder company.
Well,
Or I'll go to
I don't
somebody.
know if you get an answer there or not, but I know some people that would probably know.
Right.
So,
Right.
but the
So
idea, anyway, so do you need to agree?
No.
Maybe.
Maybe.
Because if the place you want to work and they won't talk to you unless you have a degree, well, then you need a degree.
Right.
But your experience, your abilities, and all those things really count for, one, that you master the material, take advantage of it. And two is that you can demonstrate that you have this information. Having a degree that's just not worth the paper it's on is, well, not worth the paper it's on. So,
Yeah. Well, you're right. And engineering is a great place to start. Almost any engineering degree is a great place to start for reliability for me, whether mechanical, electrical, chemical.
software.
There's a lot of software engineering, right? And then getting into a company and learning and finding out why things fail. If you're into reliability, that's the first place to look, is their records, if they have them.
Yep. Yep.
Anyway,
So that's some rant there about degrees, but hopefully it makes some sense. So if you got a degree or not, and any questions around this or some thoughts or comments on it, let us know. Head over to accendoreliability.com/go/SOR. And there you can find a widget to leave us a voice message, or you could write us a comment or a question. You can find Kirk and I and the other hosts of the show on LinkedIn or on our About pages on Accendo. And we look forward to hearing from you, as I say regularly. So
yes.
we really do.
we love questions and we love answering, and we'll talk to you any day about reliability. And we love talking to each other about it.
Yeah, well, yeah, we've been doing it for a while, haven't we, Kirk?
Yeah, I know. It's always a dynamic, thing in the industry is how products are becoming more robust, and we're getting better. I think the industry is getting better.
Yeah, I agree. All right, thanks, Kirk. Have a great rest of your day. Talk to you later.
Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.